Right, we are looking at the sketching of straight line graphs, which are sometimes referred to as linear functions that will happen in the upper grades where you're doing more graphs. We're doing this under load shedding, but this will happen, load shedding or not. So let's go. We're going to be looking at various graphs, but what's going to be crucial and important here is to know what type of graph you're dealing with when you're sketching by looking at the equation. And that's one of the things I'm going to emphasize on this video. There are three types of straight line graphs. You've got straight line graphs that cut one set of axes, and that will either be the x-axis or it could either be the y-axis. For instance, if it says x is equal to 2, we know it cuts the x-axis at 2. If it says y is equal to -3, we know that graph cuts the y-axis at -3. It's very easy. When you look at the equations, you'll only see one variable, and that represents only that as a set of axes that the graph is cutting. So if it's x is cutting the x-axis, then it will be x. If it's y, then it's cutting the y-axis. You won't have other terms there that will be part of the equation. So especially straightforward and no complications. Then you've got graphs that cut through the origin. Now here you will see the equations. They will have both the x and the y terms because the graph is cutting both the x and the y-axis. But what is happening is because the graph is cutting through the origin, the value for c, which is your y-intercept in the standard form, is 0. So that graph has not shifted away from the origin, still cutting through the origin, and you'll even see when you look at the equations, only the y and the x term appears and nothing else, and that means the graph is cutting through the origin. And we'll talk about how to sketch those. The last type of graphs that I want to talk about are graphs that have shifted away from the origin. Now those graphs, you will immediately see even in the equation, it shows that the graph has actually added a value for c that is not 0, which means that's the part of the equation that actually shows us how the graph has shifted. For instance, the graph of y is equal to -2x plus 3 means that y graph of y is equal to -2x has shifted 3 units up. It's no longer now going through the origin, and we'd even see the y-intercept, which is the value for c, cutting the y-axis at 3. So those are the three types of graphs that I want to talk about. And every time you look at your equations during the sketching, you want to be able to identify what kind of graph you're dealing with. So let's go. Look at examples. Start with the ones that cut one set of axes. Very easy, straightforward. X is equal to -3. That graph cuts the x-axis at -3. Now, very important here, when you sketch your graph, you need to show us that perpendicular symbol there, because it's very important in terms of showing what the actual graph looks like. And it's not just any graph cutting at -3, but this one is perpendicular to the x-axis and parallel to the y. Here's another example. Y is equal to 4. This one clearly cuts the y-axis at 4 and is also perpendicular to the y-axis. Very important to show that symbol, otherwise the graph is not complete when you sketch your graph there. Okay. Next ones, we're looking at the graphs that cut through the origin. What do you need to do to sketch these graphs? Hey, these graphs are pretty easy. One, you need to find your own point that you have to show on the graph. Remember, the origin is already one of the points, so you need 2 points really to sketch your graph. So the other point is the origin. Now find your own point. Here I'm using x as 1, substituting the equation. My y is 3, so I've got a point I'm going to show where x is 1 and y is 3. And on my sketch, easily I plot the point, I show the coordinates, and I draw a line through the origin through that point, and I'm done. That's it. It's that easy. And don't forget to show us your coordinates. Very, very important. Otherwise, without those coordinates, we don't know what graph you're sketching. There are so many graphs that cut through the origin. Okay, let's go to another example. Y is equal to -2x. Again, here I'm thinking of my own x value, -1, and makes y is equal to 2. So I'm going to show a point where x is -1 and y is 2. And that point will be plotted, and then show the coordinates, and then draw a line through the origin and through that point, and you're done. Okay, it's that easy. Pretty straightforward stuff. And again, look very carefully at the equations and see what is it in the equation that tells you that this particular graph goes through the origin. So let's go to the next type, graphs that shift away from the origin. How do we sketch those graphs? Now, very important that you are able to identify that my graph has shifted away from the origin. How do you see that? You still have your y and your x terms, but then you notice that there's a constant term, which is actually the part of the graph now that is a c that is not 0. For instance, in this example, the graph has shifted down 6 units, so we can immediately tell that, oh, it's no longer at the origin. So we need to find the intercepts. Now you need to find the x and the y intercept. using what we call the dual intercept method. Now, this method makes it easy for you to sketch graphs that have shifted away from the origin. So let's go. First, you're lucky if you notice that your equation has been given in standard form, because your value for C would come out easily. You will see it right there, but it's only if the graph is written in standard form. And if you are able to identify that immediately, you're able to tell that, oh, my y is equal to -6. That means on my sketch, I'll show the y-intercept is -6. But the x-intercept, you're not able to read from the equation. You then have to do calculations. And this is where now you apply a skill of remembering that whenever you find one of the intercepts, the other is 0. The same would have happened with y. If we make x 0, this whole term would have ended up being 2 times 0, which is 0, leaving us with the y-intercept. So for the x-intercept, we simply make y 0. And that simply means we end up with a nice easy equation to solve. 2x is equal to 6, x is equal to 3. Therefore, that graph is cutting the x-axis at 3. Draw a line through the y-intercept to the x-intercept, and you're done. And that is your sketch for that graph. Let's take another example. Not every time that you get a question, you're going to find that your graph is given to you in standard form, but you can still work with it. You don't have to start rewriting it in standard form if you don't want to. You can still find your intercepts using the equation as is. So let's go. Want to find the y-intercept? We cannot say without certainty that, oh yeah, is that constant. It's coincidence it happens to be that constant, because it can be another value depending on how your equation looks. So here we would have made x 0 if we wanted to, and that's exactly what we do. We make x 0, and that gives us 3 times 0, which then leaves us with 0 plus y, which is just y is equal to -12. So in this case, our y-intercept is at -12. And then the x-intercept, we have to make y 0 this time. And when we make y 0, we end up with 3x plus 0 is equal to -12. And then we solve that easy equation where x is equal to -4. I will come back at the end and explain why are we making x 0, why are we making y 0. Because it's very important, it's an important concept in graphs that we're using there. And then once we know that our x-intercept is -4, we've got our y is -12, we draw a line through the intercepts and we've sketched our graphs. Now, why are we substituting x as 0 and why are we substituting y as 0? A very important concept under graphs is that if you already know or you are given one of the coordinates in a point, you are able to find the other. And that's exactly that concept that we're using. We already know that at the y-intercept, the x-coordinate is always 0. This is for any graph, not only straight line graphs. At the x-intercept, the y-coordinate is automatically 0. So because we already know those things, we then use that concept and we substitute what we know in the equation, and then we find what we did not know. So that's why we are actually using that method there. In fact, you will see questions coming up saying maybe determine a full point. If you are given that x is equal to 3 at that point, you would go and substitute that x in the equation as 3, and then you would find the y-coordinate of that point. It's that easy. Yeah, that's it. I hope you understood the sketching of graphs. Very easy and straightforward. You must have an ability to identify what type of equation you're working with, but also calculations will show you what you want.